Bismillahirrahmanirrahim. Assalamu alaikum students. This lab is about introduction to timers, timer on. So the objective is to understand the operation of timer on and simulate the given tasks in Allen Bradley PLC. For sure we are going to use the logic simulator over here. So basically, what are timers and how do we use them and what are the needs, what are the objectives to use them? Let's have a basic introduction to this. We'll cover timers used in ladder logic programming. Timers are very important in ladder logic programming as they give the precision in time. Timer on delay starts timing when instruction is true. Timers are used to track time when instructions are on or off. They could also keep a track on a retentive base. So basically, what he means to say is that timers are the components or the devices that we use to keep a check on things or to turn on or turn off a thing after a certain time or after a certain task has completed. So how do timers do these things? We'll cover them in an example. So before we go to an example, we'll see the definition for it. The following is a list of timer instructions. You can see the timer symbol over here, timer on delay. The timer instructions say that T on is the timer on delay, T off is the timer off delay, and RTO is the retentive timer. So what we are going to use today is T on, the timer on delay. This basic component is used for the turning on of a component when a certain delay, when a certain time has completed or has passed. So here we have timer on delay, and you can see here's an input pin over here, and then there are two output pins. One is the enable and one is the done. So when you will on the timer, the enable pin will for sure turn on, but the done pin will turn on only when the delay that you have already set has completed. So there are three timers instructions: T on, T off, and RTO. What we'll be learning today is about the T on, timer on delay. Let's move to the definition of T on. Counter time based intervals when the instruction is true. It counts time based intervals when instruction is true, and then the timer on delay instruction begins to count time based intervals when rung conditions become true. So the delay will start to be counted when the timer on delay instruction, the instruction that will be giving to it on the rung as an input over here, it becomes true. So when it becomes true, the timer on delay will set the timer to on and start counting the time till we reach the preset time. As long as rung conditions remain true, the timer adjusts its accumulated value ACC. You can see this accumulated value ACC each evaluation until it reaches the preset value BRE. So here's a preset value that's you can see over here to be set to be 100, and then is a accumulator value, and you can see that it says that as long as the rung conditions remain true, the timer will adjust its accumulated time until it reaches the preset value. The accumulated value is reset when rung conditions go false, regardless of whether the timer has timed out. So if during the process when the timer is counting the seconds or the time steps, if during that process the enable pin goes off, the timer on delay input goes off, the timer will reset itself and the accumulator value will go back to 0. So no matter what the value, if you turn the T on timer off, the timer will reset itself and the accumulator value will go back to 0. Then it says that each timer on delay is made of three word elements. That's very important thing. So what are the three word elements? Word 1 is the control word, word 2 stores the preset value, and word 3 stores the accumulated value. So preset value is stored in word number 2, accumulator's value is stored in word number 3, and the rest instructions are the control word instructions, which are stored in the bits 0 to 15. So how do we address these bits? We'll see in a while when we do an example. Bit 0 to 12 is for internal use of the timer, and then on bit number 13, the done pin, this DN pin, we have the done pin on bit number 13, and this bit will turn on when the accumulator value reaches the preset value. Then we have the bit 14 bit 14 in the first word, and this is for the timer timing DT bit. This is basically the bit which is on when the timer is timing. That is, when the timer is processing the value for the accumulator to reach to the preset value. Then we have the bit number 15, which is the enabled pin, EN pin. You can see it over here. This bit is on when the timer is energized. So when the timer is energized, that is timer on delay is getting an input, the enable bit number 15 will be on. Similarly, the timer timing TT bit number 14 will be on when the timer is counting the time, and bit number 13, the done pin, DN pin, this would be on when the accumulation value has reached the preset value, that is the time that we need or we had planned to pass has passed. So bit number 13 will turn on when our timer has counted the required amount of sets of the steps or the time that we had given to it. Now the word 2 stores the preset value, PRE. The programmer specifies this value. You are the programmer for it, and when the accumulated time reaches the preset value, the controller sets the done bit. We already know this. When the accumulated value becomes equal to or greater than the preset value, the done bit is set. Usually preset value is from 0 to 32, 767. So the preset value has a range, and you can see that it says that the preset value is stored in the word number 2, and you are going to set this value, and when the accumulated time will become equal to the values that has been set by you, the done bit will turn on. If a timer preset value is negative, like somebody has created a problem or there's some issue and you have programmed a negative value by error in the timer preset value, then an error will occur because for sure we can't move negative in the time domain. And then we have the word 3, which stores the accumulated value. So word number 1 was storing the control word, it was performing the operations. Word 2 is storing the preset value that is being set by us, and word 3 is the accumulated value, which is basically the time that has elapsed since the timer was last reset. This should be remembered that the timer will reset itself once you turn the input off. So the accumulated value is the word 3, and it is basically the time that has elapsed since the timer was last reset. When enabled, the timer updates this continually. Okay, so then comes the time base. It's the timing update interval, and this can vary from 0 to 1 second. This is the base that would be used for counting the time, and you can see that it says that the timing base can vary from 0 to 1 seconds. So you can set the timing update interval to be 0.1, 0.2, 0.3, or any value between 0 and 1 seconds. For sure you should not set it to be 0 seconds, because it is basically the base that is being set or being used by the timer on delay for this time counting process, and the value which would be attained by the timer on delay, and the time that would be taken by the timer on delay to reach the preset value would be basically measured in this time base intervals. So let's move to the example that I need to explain to you. That would be basically based on simple timer on instructions and examples. Let's move to it. There's something that I've already built, but what we'll do is that we'll just delete this one and make a new one. So here we are, and we're going to implement some logic circuit with the use of timers. So you can see that here we have the user and here we have the timer counter. We'll place our input switch over here, and here it goes over here. Now I'll click on timer counter and we are going to use the T on. I've pressed on T on and you can see that the timer on delay switch, the timer has appeared over here. Now what we need to do is I'll just place an output at the end. I've just clicked on the output and an output has appeared over here. Now I'll just rename these input switches with 1/0 and then this output switch as output 1/ sorry, we're going to name it with 2 because you can see that it starts with 2. So here it goes. Now we'll just download this to PLC and let's see what happens. It has been downloaded to PLC. I'll go online, select run. Okay, I've just skipped a step, so I'll go offline. What I've skipped is that we need to set the values for the timer. Here you can see that it says what timer are you going to use. So I'll just place over here T4:0. You can even use the T4:1, :2, :3 or any of the timer bits, but we are going to use the timer T40. I guess we are given 256 timers, so you can see okay, we have T4 till 99 and here we are with T40 that we are going to use over here. Now it's asking me for the preset value, which can be the time that we need to set or the timer delay that we need to set. So I'll just set 100. Okay, then we can see that the accumulator value has been set to 0 and the time base is 0.1. So if we travel with 0.1 and we need to reach the value of 100, then you can see that if we multiply 100 with 0.1, it results in 10. So that means that we are giving a delay of 10 seconds. We are turning the timer delay on for 10 seconds. Let's have a look at the outputs. I'll just download it to PLC again. Now I'll go online, I'll run it, and I'll just turn the input switch on. You can see that the accumulator timer has started and it's quite fast because it's with the time base 0.1. and here when we have the accumulator accumulated 100 seconds and which is 100 points, which is exactly equal to the preset value, the done pin turns on and the enable pin was already on when the input to the timer was on, and now I'll turn it off. You can see when I turn it off, the accumulator has reset itself to 0. I'll turn it on again. You can see that the enable pin is on, the accumulator is counting the time steps, and if I turn it off over here, you can see that the accumulator has reset itself again. So turning the timer on or off will reset the accumulator every time with the value 0. So that's all that you need to know about the timer on, and here you can see that the done pin has turned on. Now let's move towards the use of done pin. So what do we mean by done pin? I'll go back to offline mode. I'll place an input switch over here and an output over here. So I'll just give this input switch the address of done pin. So how am I going to do this? I'll write T4, which is basically the timer address, then 0, and now I have to give it the bit of the timer, which is the done bit, and you can see in the manual that the done bit was the bit number 13. So I've written 13, I'll press enter, and you can see that done has appeared over here. I could also write DN instead of 13, and you can see that it has also understood my symbol over here. Now if you write 14 over here, you can see that it has gained the TT switch, which is basically the bit when and it's on when the timer is processing or you can say counting the time. And here we can also write 15, which is the enable pin, and you can see this bit has appeared over here. But what I need is the done pin, so I'll just write done over here, and here we can write the output number 02/1. So this is this output. Now let's see what we have done. I'll just download this one to PLC and I'll go online. I'll run it, and now let's see what happens. I'll turn the switch number 1 on. You can see it over here. The accumulator has started counting the bits according to the timer base, and you can see when the accumulator counted the time 100 according to the preset value, the done pin was enabled, and when the done pin was enabled, the second output also turned on. Now if I turn this off, everything has turned off, and now if I turn this back on, and before that this has reached to the preset value, if I turn it off, it has reset the accumulator value. I'll just turn it back on again, and we'll wait, or we can change something else too over here. Change the preset over here, we can change it, but we are not able to change the timer over here. So what I'll do is that I'll change the preset to 1000. So you can see that instead of changing the time base, I've changed the preset value to 1000, and now I'll run it. I'll download this to PLC and I'll go online. And now I will run it. You can see that here it is counting accumulator, and it will go till 1000, and so you can see that it has started running, and it will run till the value has reached the preset value, which I have set to 1000 right now. So that would be equal to 1000 multiplied by 0.1, which is 100 seconds. So we'll have to wait for a minute when till this switch will turn on, because it's getting the input from this done pin. We can also change it to the enable pin, and it will turn on as soon as the timer gets the enable switch. So till this process completes, we'll move to the tasks. So exercise 1 says that you need to design a ladder diagram for the scenario. Output to turn on after 10 seconds of input goes to logic 1. Input cannot turn to logic 0 within these 10 seconds. Input can turn to logic 0 within these 10 seconds. So I guess that's pretty much easy after I have done the example for you. That's very similar, very easy. Now let's go to the exercise number 2, which says that let's say we have in the field an emergency stop push button. Once the emergency stop is pressed, we want the siren to go on after 5 seconds and for 5 seconds. So I guess that's very easy, that which pin are you going to use. You have three options: enable, done and TT. So you can see that it says that you want to turn the input on after 5 seconds and then only for 5 seconds. So that's not an something that you can say that it's difficult or something. It's very easy. So let's move to the exercise number 3. Let's say that we have a conveyor, siren and one limit switch, LS01. LS01 is at the beginning of the conveyor. When LS01 is on, we want our buzzer to go on for 3 seconds. Okay, so we have a conveyor, a siren and one limit switch. LS1 is at the beginning and LS1 is on when we want a buzzer to go on for 3 seconds. That's the security. And then we want to start the conveyor. When LS01 is cleared, then we want to stop the conveyor. So I guess it's pretty easy when it says that the first output, that when the first output is on, then we want to turn a component on for 3 seconds, and then we want to start another input at the output of this component, and when the output of the first component has cleared, that is it's done, then we want to stop the conveyor. That is, in industrial meaning, it means that when the component has processed the equipment or anything else, then we want to stop the conveyor. So that's all that you need to perform in this lab, and I hope the tasks are very easy, and I've made it quite in an understandable way. But still, if there are any issues, you can ask them in the comments or anywhere else. I would be there to help you out. Do try this, and if you face any difficulty, you can contact me. Take good care of yourselves. Allah Hafiz.